Welcome to ePathshala lecture series on computer science. In this module of data analytics, we will be discussing about how analytics have evolved over a period of time, and also we will be analyzing what are the various technologies related with data analytics. So, what are the learning objectives of this module? In this module, we will understand what are the various stages through which data analytics have come through, and we will also understand what are the technologies related with data analytics. So, to start with, in the recent days organizations are trying to deal with voluminous data. Now, the data with which they are dealing are not the same as they had in the earlier days. So, what is here is the older technologies that were used for the purpose of analysis cannot be applied now on this data. So, hence what is that we need to do is we need to look in for alternative technologies that can handle voluminous data with lot of uncertainties. So, there are certain technologies which will be in a position to handle big data. They are MPP, which is nothing but massively parallel processing architectures or servers, then the cloud environment, grid computing environment, and MapReduce environments. Actually speaking, the big data that we are currently dealing and the analytics that we are trying to make use on these big data have converged over a period of time. We had to pull all data that we want to analyze in a traditional analytical environment into a single environment or a centralized environment, and then we will have to apply analytics. So, what happens is the data sources will be different and the data that is available will be heterogeneous in nature. All that we need to do is we need to collect the data from such heterogeneous data sources, then we need to perform some level of pre-processing on the data, because when we deal with an unclean data, the analysis that we run will result in a wrong conclusion. Therefore, some level of pre-processing need to happen, and after pre-processing the data need to be placed in a centralized server, wherein analytical algorithms will be executed over this data and the analysis will provide results. So, in this diagram you can have a picture of a complete picture of what has happened in a traditional analytic architecture. So, you have variety of data sources from where we pull the data and then we place the data in an analytical server or in a PC. So, the heavy processing actually occurs in this analytic environment. In modern database architectures, what actually happens is, though data are available in different data sources, the data are pulled from such sources, then processing happens, and then all these data are integrated and the final quality data will be held in a consolidated fashion in some common storage. For example, it can be an enterprise wide data warehouse. So, what happens is we have different data and data sources, we pull all these data may be relevant for the analysis or irrelevant for the given analysis. So, what is that we need to do is we need to do some level of pre-processing over the data, then get the quality data, consolidate it and then place it into the enterprise wide data warehouse. So, we will be having separate or specialized schemas with which such data will be held in the enterprise wide data warehousing environment. Now, what happens is when we want to run the analysis, the users actually can provide queries from say an analytical server or a PC. So, all that happens is heavy processing does not happen in this analytic server or PC environment. Instead, the analysis is happening in the place where you actually have the data itself, that is inside the enterprise wide data warehouse. This is what is happening in modern database architecture. So, what exactly we can infer is the analysis that were performed outside the place where we had data now has been converted or modified into analysis running inside a place where we have the data itself. So, for such kind of analysis we need to deal with different technologies, because the volume of data is very high, and moreover when we run a query, the query when run on a voluminous data will take more time for processing. So, we need to go in for some level of parallel processing. So, we need to deal with certain architectures or servers or environments or frameworks that offers distributed processing as well as parallel processing. One such architecture is MPP, which is called as massively parallel processing system. So, in massively parallel processing system, actually what do we have is, we have loosely coupled nodes. These nodes are linked together by means of a high speed connection. Now, this massively parallel processing environment, though the nodes are associated or connected with storages, separate storages, what actually happens is, when we are trying to run a query, the query need to be subdivided into subqueries, and the subqueries will be assigned to different nodes, and the nodes will be doing the processing with respect to the data they have. In other words, the data that is available to a particular node is not made available to the other node. Therefore, it is said to be a shared nothing environment. So, disks are not shared, each being attached to only one node. That is the reason why it is called as a shared nothing environment. This massively parallel processing environment, the architecture is shown here. So, we have different nodes, each and every node is associated with some number of CPUs, and say the internal bus actually connects this to various local disks or data sources. Similarly, you have another node with its own storage, the third node with its own storage. Likewise, you can have n number of nodes. All these nodes are connected to high speed interconnect. Now, from this diagram, we can understand the data or disk that is associated to a node is specific only to that node, or the disk is not shared across the nodes. So, when a particular node does not have a data, then it cannot depend on another node's data. That is why it is said to be shared nothing environment. When we talk about shared nothing environment, we should also know there is an alternative called shared everything environment. This is known as SMP architecture. SMP architecture is symmetric multiprocessing architecture. In symmetric multiprocessing architecture, we will be having data stored in disk that are shared by more than one node, which is an alternative for MPP. But in majority of the data warehousing environment, third parties often offer MPP architecture as a best solution for processing data or running analysis. Now, what exactly happens in this massively parallel processing environment? For example, assume you have 1 terabyte of data in the storage. Now, when you have a single server, what is that we need to do is, when I run a query or when I want to execute a query, this single server will run the query on the data, 1 terabyte of data available in this table. So, it has to take row by row or record by record and then run the analysis. Now, the time taken for running such queries will be very high, but this can be reduced, that is, the running time can be greatly reduced when we are going in for an MPP architecture which supports parallelism. What happens is, we will be having multiple servers or multiple CPUs, and then we will have the data divided into partitions or distributed across various nodes. So, the same 1 terabyte of data will be divided for example into 10 partitions. So, 100 GB of chunks will be available in each and every storage. So, what is that we are going to do is, we will be taking a query, we will not be executing the query using one single server, instead the query will be divided into subqueries. So, each and every subquery will be assigned to the servers that are available here. The servers will look in its own data storage environment or its own disk for the purpose of availability of data and then execute the task. Now, what happens is, one single query is divided as 10 subqueries and all the 10 subqueries are executed in parallel. Therefore, the time taken for executing the query in a single processing environment when compared with this MPP multiprocessing environment naturally will be very less when compared with the single processing environment. So, whatever I have explained is shown diagrammatically here. So, in a single thread process, what happens is, the query initially works on say the table, it collects data row by row, do the analysis in a linear fashion and finally, we get the result. But in an MPP environment, the same job is broken into pieces and each and every piece of job is assigned to different servers. The different servers will connect to their storage environment, take the data, do the processing and finally, the processed partial results will be merged together and provided as one single result. So, here it is parallel processing, here it is a single thread process. So, this is the major difference between our traditional single or uniprocessing environment and MPP processing environment. In massively parallel processing environment, since the data or disk is not shared across nodes, there is a chance for few queries to depend on data that is available in another node. Therefore, for the purpose of making some level of sharing of disk in massively parallel processing environment, people make use of shared distributed lock manager, and this shared distributed lock manager is a software that maintains the integrity of the distributed resources across the system. The CPU power which is made available in MPP architecture completely depends on the number of nodes that can be connected, and moreover MPP system actually some built in redundancy. This is essential. The reason is when a particular node is out of data, then it cannot depend on another disk. Therefore, some level of redundancy is applicable in MPP environment, and also MPP environment is associated with resource management tools that can manage the CPU and the disk space. Also, it has a query optimizer which will be useful for the purpose of identifying a proper query plan to execute the query in a very shorter time span. The next important environment that is closely associated with big data is the cloud. Cloud has been defined by many people and it has got various features. McKinsey and Company has published a paper titled Clearing the Air on Cloud Computing, which was published in 2009, and in that paper they have listed 3 important features associated with cloud computing. The first feature is mask the underlying infrastructure from the user. Here in cloud computing, what happens is we will be having a node. The node need not have enough computing capability for achieving a task. It will be a thin client here in the sense it will have limited memory as well as limited processing power. Therefore, when you want to deal with a voluminous data, it is not possible for us to execute that voluminous data in a thin client. In a cloud computing environment, when we want to run the same query, then we need not worry. Instead, what is that we can do is we can make a request for say extra computing capability from the cloud environment. So, when we require such a computing capability, we need to pay and use for it, or when we want to store some voluminous data, even though we do not have enough of storage capacity in the thin client environment, we can depend on storage that is available in the public in cloud, or it may be stored in an environment that is private to a specific organization. So, here in cloud computing, mask the underlying infrastructure. What does it mean is when I want to say store the data in say a cloud environment, how exactly the data is stored, what format is associated to the place where I am trying to store, what type of computing capability that particular environment has, nothing is known to the user. All that the user knows is a service that is provided and the user makes use of the service. Now, for the purpose of making use of the service, the user has to pay. So, on a pay per use basis, we normally deal with various services, and also whenever I want to expand my capability both in terms of computing as well as in terms of storage, this cloud computing environment is said to be elastic in nature. So, it is elastic to scale on demand or as per demand. These are 3 important features or characteristic factors associated with cloud computing environment. Apart from this, National Institute of Standards and Technology NIST also has identified key features related with cloud computing. They are on demand self service, broad network access, resource pooling, rapid elasticity and measured services. So, these are all going to be key features related with cloud computing environment. So, in this environment, it will be easy for everyone or anyone to do voluminous computing as well as to handle voluminous data. There are 2 types of cloud computing environment. One is public cloud, another one is private cloud. Public cloud, the services and infrastructure are provided off-site over the internet. In other words, everything is going to be public. So, everything is in the form of a shared resource. Whenever we are offering certain thing in the form of a shared resource, there is lot of chance for less security. So, public cloud is less secured and more vulnerable than private clouds. Now, what is a private cloud? So, private cloud, we offer infrastructure and we offer resources solely for a single organization. Since it is dealing with a single organization, there is no chance for any vulnerability towards security. Therefore, the data or the processing capability or the environment itself is said to be completely secured. So, it is highly secured and the control is completely with respect to that organization and necessary to purchase and own the entire cloud infrastructure. So, some amount of money need to be invested for the purpose of coming up with a private cloud. The third important environment that is associated with processing data in a distributed fashion as well as dealing with a voluminous data is grid computing. So, grid computing is actually a form of distributed computing in which we will be having a super or a virtual computer which is composed of clusters of networked loosely coupled computers. So, what these computers are trying to do is, though they are not single, it is distributed. In other words, though we are not going to have one single computer that can hold voluminous data or a supercomputer that can hold a voluminous data, we try to identify nodes across the internet or nodes in an internet environment, in an internetworked environment which can offer space as well as which can offer processing capability. So, that is what we call as grid computing. Grid computing is actually a growing technology and executions of large scale resource intensive applications can happen very effectively and very efficiently in grid computing environment. Grid computing environment offers or facilitates flexible, secured, coordinated large scale resource sharing among dynamic collections of individuals, institutions and resources. Therefore, data that is held in a distributed environment can be processed very effectively and in a parallel manner. So, this is an example for a grid environment SETI. So, what is SETI is search for extraterrestrial intelligence. This is actually an internet based public volunteer computing project wherein lot of details about the space and events occurring in the space are being captured and held in that server. So, anyone who wants to run an analysis will be provided with 2 terabytes of data over which we can run any statistical analysis or mining algorithm and come up with pattern. So, this is actually an open project which deals with presence of extraterrestrial information in the universe. The most recent environment or framework that is closely related with big data is MapReduce. So, what exactly is MapReduce is? MapReduce is a parallel programming framework. This MapReduce actually has 2 important functions. One is the map function, another one is the reduce function. What does this map function will do is, map function will process a key value pair to generate a set of intermediate key value pairs. So, these key value pairs will be useful for identifying the presence of a data in a storage or a block of data in a storage environment. So, fundamentally we need to identify the data that we require which is held in a storage environment. So, map function will do this functionality. Once we have identified the data that we want to process, then what is that we need to do is we need to run the analysis. So, the map function after identifying the key value pairs, then it will run the analysis. Now, running the analysis will be happening in a distributed fashion. So, the data that is available will be in a distributed form. The analysis that we are going to run will be run or executed in a parallel format, and hence we will get intermediate results from different map functions. All these intermediate results need to be combined together. So, the second function called reduce function will be merging all the intermediate values associated with map and it will be combined together and the final result will be provided. So, these are the 2 important functions related with MapReduce environment. So, how does MapReduce works? Let us take an example and understand how exactly MapReduce works. Assume there are 20 terabytes of data and 20 MapReduce server nodes for a project. The data is actually distributed. In other words, these 20 terabytes of data are divided and distributed across these 20 MapReduce server nodes. So, we will be having 1 terabyte of data in each of the MapReduce server node. Now, what is that we need to do is, we need to provide a map function and the reduce function. So, submit 2 programs, one is the map, another one is the reduce to the scheduler. Now, what the scheduler will do is, the scheduler initially runs the map program for the purpose of finding the data that is on the disk, and then it executes a logic it contains. So, we need to identify where exactly the data is available. Having identified the data, next we need to run the logic over the data. The application of logic over the data will result in various answers. These answers are going to be intermediate answers. So, such intermediate answers or results need to be combined together. For this purpose, the second program, which is the reduce program, will take all the intermediate results and then it will combine them or aggregate them and then summarize them. Now, the summarized information is what is going to be given out as a result of this MapReduce function. So, this environment, which has two functions, the map function and the reduce function, will take the data, do the analysis, return intermediate results, and finally combine these results and provide a cumulative or aggregated result. What are the pros and cons of this MapReduce environment? MapReduce environment actually is good for dealing with lots of data or lots of input. So, you can have lot of intermediate output or intermediate input data. We can deal with lot of output data or intermediate output information. So, MapReduce can work well for lots of data. It is also batch oriented in nature. In other words, it is closely related with extract, transform, load kind of jobs. Extract, transform, load, what exactly it means is, data when available in different data sources need to be extracted from these data sources. So, when we want to run a query, it is not going to be a simple query, it is going to be a kind of bulk loading or say batch processing kind of task. So, in such scenario, we will have to run the query for a longer duration, sometimes even it may take more than 24 hours for the purpose of extracting the data. Then once the data is extracted, we need to run some transformation over the data. What may be a transformation? For example, I have collected data, one from a US server, another one from Indian server. Assume these data are transactional data. Now, the transactional data will have some currency value. The data that I have extracted from the US server will be in dollars, and the data that I have extracted from Indian server will be in rupees. Now, when I want to run the analysis, either I will have to convert the dollar, that is dollar information to rupee information, or rupee information to dollar information. Whatever it may be, it is considered to be a simple example for transformation. Now, when I want to run the transformation, these transformations need to be applied on the data. These data are going to be voluminous in nature. Hence, this is going to be another kind of batch processing example. So, I need to transform the data. Having transformed the data, then I will have to load this transformed quality data into a temporary storage environment or the main storage environment where I want to run the analysis. So, loading the data, once again it is going to be voluminous in nature, which will be bulk loading. So, it is going to be a kind of batch oriented jobs and batch oriented databases. So, when I want to do some analysis in batch oriented databases, MapReduce will work fine. Then it is cheap to get up and running, because running on commodity hardware, it is going to be very simple and it requires less cost for the purpose of running on commodity hardware. That is why MapReduce is widely used for the purpose of data analytics or doing some kind of processing on voluminous data. Apart from various good points, we also have various cons related with MapReduce. One important thing is, when you want to have a fast response, then MapReduce normally will not offer you a fast response. Large amount of shared data is there, means MapReduce offers you less efficient results. Then if it is going to be CPU intensive operations rather than data intensive, MapReduce will not help you out. And this is not a database, MapReduce is not a database. So, once it is not a database, then there will not be any built in security, then indexing mechanism will not be built in. Therefore, we need to go in for effective indexing, and knowledge of other data does not exist in case of MapReduce environment. Because of these cons or drawbacks, in certain scenarios or in certain environments, MapReduce may not be applied. Now, having understood how analytics have evolved over a period of time and what are the various types of technologies that are used for analytics. Then we should understand finally what is that we are going to do. Finally, we need to find integration of technologies only for the purpose of dealing with big data. The reason is there is no one single technology or one single complete technology that can handle big data effectively or efficiently. So, what are the various technologies that are available in the world and how these technologies can be integrated together? That is what we need to understand, and that is what we need to consider for the purpose of analytics. So, few examples of technologies which can be integrated and that can work together towards big data analytics are given here. So, we can have databases running on the cloud. For example, SimpleDB and Microsoft's SQL Azure are examples for cloud databases, that is databases running on the cloud. Then we have databases that includes MapReduce functionality. So, Teradata, Aster and Oracle actually have MapReduce embedded in the database. So, these two databases can be extended for MapReduce functionalities. Then we have MapReduce which can be run against data source from databases. For example, Couch database and Mongo database are databases where MapReduce is already embedded, that is you can run MapReduce against these databases. We also have MapReduce which can be executed or which can be run against data in a cloud. So, cloud MapReduce is another environment where you can have or run MapReduce in the cloud. So, such kind of technologies are available. We need to make use of these technologies, bring them together, that is integrate them for the purpose of handling big data. Only then analytics can be performed effectively and the outcome of analysis will be very effective. So, what is that we have understood from these discussions? We have understood that analytics has evolved along with technology. We have found in the evolution of analysis no single technology has been applied. So, analysis has evolved over various time or duration and also along with the technologies. There have been different technologies that have which has been identified for the purpose of making analytics very effective. The second important conclusion that we make is currently many technologies are available, but we cannot identify one single technology that may be used for effective analytics. The reason is when we deal with respect to big data analytics, we are actually not dealing with a structured data. We are dealing with say a data that is voluminous, that is having a different rate at which the data arrives. There is lot of uncertainty with respect to the data, as well as we are dealing with respect to say unstructured or heterogeneous data sources. In such a scenario, we cannot depend on one single technology that can deal with all these 4 parameters. That is the reason why we need to identify more than one technologies or frameworks which can be integrated together either in a single framework environment, or we can take intermediate results of our analysis and use in different frameworks for the purpose of making analytics very effective. So, we have identified many such technologies wherein different forms of databases are available, databases in the cloud, MapReduce running on the cloud, as well as MapReduce running on the database environment is also available. All these technologies need to be identified properly, integrated together for the purpose of doing analytics in a very effective manner. Thank you.